Okay, everybody, let's recap and talk about polynomials. So, polynomials, first of all, are expressions that have whole number exponents. Whole number exponents. Example, let's start here. Let's start right there. Polynomials have whole number exponents. So those are like the numbers like 0, 1, 2, 3, 4, 5, whole numbers, okay? So an x squared is a polynomial. An x cubed is a polynomial. An x to the fourth is a polynomial, and x5 and so forth and so on. Okay? Now what we talked about in all of these polynomials, they all have these curvy, wiggly shapes, all right? If it's degree 2, like a parabola, it's just going to have this shape or this shape. So what we know about it is it's always going to have two answers. X squared always has two answers. And the two answers can be two real answers, one that has a double root, or no answers, and those are going to be called our imaginary answers, okay? It also has extrema. So the extrema are either the top or the bottom of the hill. That's an extrema. And with a parabola or an x squared degree 2 equation, there's only one extrema, that's the top of a hill, or the bottom of a hill, okay? We move to x degree 3, and you can have a variety of these shapes, but they all wiggle. Here's x cubed, here's another x cubed. We can put these on the graph, and the more terms it has, the more it wiggles, okay? The more terms it has, it wiggles, okay? So degree 3 could have as many as, we know, 3 answers, 3 zeros, has to have 3 zeros, but some of them are imaginary and some of them are what we call double roots or double zeros, 3 zeros. This one has 1 0, but it repeats itself 3 times, 0, 0, 0, okay? This one has 1 real 0 and then 2 imaginary. This one has 1 real here and then what we call duplicity or a double root here, roots, zeros. Keep talking about that, same kind of thing. And then this one will have 1, 2, 3 real roots, okay? And then we want to talk about extrema, and with an x cubed you could have no extrema, because extrema is the top or bottom hill. This one has 2 extrema. This one has 2 extrema, a maximum and a minimum, okay? Now, end behavior, we talked a little bit about end behavior as, let me get a different colored pen here, as end behavior, as in this case x approaches infinity, y approaches infinity, and over here is x approaches negative infinity, y approaches negative infinity. But it's not always like that. For example, we took a look at maybe one that has a slightly different orientation. We'll look at that one. Actually, we'll look at that one coming up later, okay? For end behavior, okay? Now, increasing, decreasing. Let's take a look at this graph right here. Let's call this point A, point B. This graph is increasing from negative infinity to point A, which is probably negative 1 for the x. And it's also increasing from point B, which is at probably 2 to infinity. Decreasing is going downhill, which is from A to B, and it's decreasing from A to B, which is at negative 1 to 2, okay? All right, now let's look at x to the fourth equations. Degree 4 have even more wiggles. Could look like this, could look like this, could look like this, it could look like this, and it could look like this, depending on how many terms it has. So it has always 4 answers. It's always going to have 4 roots because it's degree 4. This has 1 x-intercept, but we would call it a duplicity of 0 4 times, okay? This has 1, 2 real roots and 2 imaginaries. This has 1, 2, 3, but that's a double, so it really has 4 real roots, but that's a double. This one has 4 imaginary, never crosses the x-axis. It says 1, 2, 3, 4 real roots, okay? And then we went into Desmos and worked on a polynomial exercise on Desmos. We did have homework today, and our homework's on page 217 and 218, which I'll post on campus. Okay, that's about all I have on polynomial behavior. They wiggle, and they have different end behaviors.